Okay, this is where we left up last time. Just want to do everything completely. So last time, at the very end, we just were identifying the growth factors, which is kind of the most important thing for each of these different time periods, right? So what have we seen? That in exponential growth, there's not just one growth factor. That's what we started off saying, that there's a growth factor, decay factor, but then we saw you can pick different intervals of input, and you can get a growth or decay factor for any interval of input that you choose. So we were given here the 5-hour. It said removes 85% every 5 hours. So that got us the 5-hour decay factor of, so it removes 85% every 5 hours. And the 5-hour decay factor was 0.85, right? Is anybody awake? 0.15, right? If 85% is the decrease, remember our decay factor represents what you keep, right? What portion you keep. So this 85% every 5 hours means we keep 0.15 every 5 hours. So that's a 5-hour decay factor. But then we saw we could get a 1-hour decay factor, a 1-minute decay factor, a half-day decay factor, and we can write a function for all those different time intervals of input. So let's just take 5 minutes to either redo this or finish up what we didn't do last time. So this is a really important slide because there's so much it's making use of or kind of assessing everything we've done so far to see if you understand it. Okay, so I want to finish this and get all the answers that you're confident about everything you're doing on this. So take 5 minutes to reorient yourself, pick up where you left off. Write out these. So basically, we're writing out the function for each time interval, and we're getting the percent change for each interval. Okay, so I'll actually take attendance. Jerome can help you as he walks around. Good. Okay. This Joshua. Did you get G of T? $500. 0.684 to the m. Because 0.684 is the 1-hour growth factor. Is that exact or approximate? All right, so we want to write it exact. Some of these web work problems, they force you to write it exactly, and that's important that you know how to do that. So if we wanted to write it exactly, it would be 500 times. Christopher. To the 1/5. A T, right. I missed it. This is T. Okay, so how do we do on G of T? So there's kind of trade-off in each one. 0.15 to the 1/5 is exact, but if we want the 1-hour percent change, we're going to use this other one because that shows us what 68% every hour. What happens? What's 68.4% mean every hour? We keep that much. So the percent decrease is, or the percent change, will be negative 31.6. So with this decay, if it says percent change, then that percent is going to be negative. If it says percent decrease, then positive, because it's the decrease, as you're saying, how much does it go down? That's a positive amount that it goes down. As a change, that's a negative. Questions on 3? Questions on 3. Okay, let's see. Who's up? Britain. P of M.
500 times 0.684 to the T over 60.
To the 1/60th, okay. Is that the function?
Or M60.
So you want m over 60? Yeah, m over 60 does it. I'll just stack it down here at the end. So he said m over 60, which is fine as well. So you could put the m over the 60. Let me write it because it's getting a little weird there. What's that? So 500 times 0.684 to the 1/60th to the m. And that's the same as m over 60. M over 60. How are we going to get the 1 minute percent change? Sebastian. Sebastian, how are we going to get the 1 minute percent change? How are we going to get it? Not sure? Okay, so here's the theme we're going to talk about later, that a percent change for a particular change in input has to come from that corresponding growth or decay factor. You can't get it anywhere else. This is a huge theme today. You can't get that anywhere else. It has to come from the growth or decay factor for the same time change. There's no other route to it. And we'll see. I'll have a nice map for you. So, Matt.
Negative 0.6%.
How'd you get it?
1 minus the decay factor. Whatever 0.684 is 1/60th, and I got 0.994.
All right, so, and I'm going to do it exact. So where did the 0.684 come from? 0.15 to the 1/5?
Yeah.
So we'll do 0.15 to the 1/5, which is which decay factor? Which one's that?
That is the 1 hour decay factor.
1 hour. And what are we going to do with that?
Put that to the 1/60th.
1/60th to get the?
1 minute.
Good.
And then you would subtract all that from 1. It would leave you with about.
So I'm just going to find that right there. Is that the 1 minute decay factor? So did I make a mistake somewhere? I think I got it right. .15 to the 1/5 to the 1/60th. So when I put that in, I get .943. Does someone else get that? You got that too?
I got 0.993.
How many people got .943? How many people got .99? Something's wrong with what I'm doing here. What am I doing wrong? Oh, I know. I see it. Hold on. I got some parentheses around 1/5 that I need. Haha, thank you. Okay, cool. So that's the, explain that number to me. So what does the .9937 mean? What is that talking about? Nick King, what is that number talking about? Okay, so pay attention. Okay.
That's how much you keep, basically.
Every,
What's still left after the amount of time.
that's how much you keep every
Minute.
minute. So if we want the percent change, so Matt, take it back over again.
Okay, so you you would do 1 minus the decimal value there.
Okay.
And convert the 0.993696622 to a percent, and then subtract from 1.
I'll do it this way.
Yeah, that works.
Now that's a percent. That's a percent, not, so that's actually less than 1% change, right? So that's the actual percent change there. Okay. Question on that. Number 5, Q of D. Adam wants to do it. Can we do it out long way? All right, let's do the 12th, okay? I can't hear you now.
Yeah, that's,
Is that the function?
well, no, because you still need D for the input, so I had 0.15, 12 over 5,
Okay.
and then where you have 12 at, I put D. Yeah,
Let me write it out again over here, because this is kind of hard to read now that we got so many growth factors going on, decay factors. So 500 times the 0.15 to the 1/5. Is that the 1 hour? To the 12th, 12 hour or half day, to the D. So what's an advantage to the way I wrote it in blue there? So there's an advantage to that. What's the advantage to that?
it's way more exact.
What's that?
It's far more precise.
Okay, so it's exact, definitely exact, but there's also another advantage to it. Yeah, Danny.
You can see where you're getting your numbers from.
Right, you see every decay factor along the way. You see how many decay factors are there? How many decay factors are there? There's 4. Name them. What's the first one?
The original.
5 hour, 1 hour, 12 hour, and then the number of 12 hours. So the whole thing you can think of as the D 12 hour decay factor. So once you pick a D, once you pick a value of D, say 10, then you're talking about the 5. The whole thing is the 5-day decay factor. If you pick D equals 10. Nice. All right, percent change. So all that stuff in there. See if I can get it right here. So equals 0.15 to the 1/5 to the 12. Did you get this also?
Yes.
0.0105. So what's the half-day percent change, Mitchell?
That 1 minus that.
Uh-huh. So we'll do, is that 10% or 10? 10, 1%, there, yeah. 1.053 minus 100. Did you get negative 98.95% change over half a day? Seems about right. Like you take 2 or 3 ibuprofen in half a day, most of it's gone, right? Most of it's out of your system. Okay, questions on these decay factors and percent change? Yes, sir?
So when it's percent change, we just add a negative sign in front of it?
If it's decay, if it's going down.
Okay.
Not if it's exponential growth, then the change is positive. Yeah. But if it asks for a percent decrease, so what's the half-day percent decrease?
It would be 98.
Positive 98, because the decrease tells you it's how much it's going down. So if you say a decrease of negative, that's actually increasing. So doesn't make sense. So yeah, so if it's talking about decrease, you talk about decrease as a positive percent. If it says percent change and it's a decrease, then you need a negative. Okay, so I need to find. This is not what I wanted. We're going to find that. There it is. Everything's okay. Okay. So, what's the centerpiece? What's the main idea of exponential growth? What's the main idea? What's that? Multiplication by growth factor, decay factor on, what does it multiply on? To get another output. Good. Nice. Growth factors. Growth factor is a multiplier on an output to get another output, right? Or decay factor, right? Or decay factor. Okay, what stays consistent from output to output? Well, that's true. A little bit trivial, but that's true. Oh, percent change. I pushed too fast. All right, so what stays consistent from output to output? Percent change. So two ways to, and I bet you were disappointed too, that I spoiled it for you. Yeah. All right, so two different ways to look at exponential growth. A consistent percent change every change in input, or multiplication by the same number, a growth or decay factor, every change in input. Okay, so those are both ways to characterize exponential growth. And remember that our growth factor is 1 plus whatever that percent change is as a decimal, so they're very closely linked. If you have a growth factor, you can easily get that percent change. If you have a percent change, you can easily get that growth or decay factor. Okay, that's the decimal version. So that's all review, right? That's all review. So let's talk about here, I kind of mentioned earlier about this thing about percent change. We're going to focus more on percent change now. So we have the 1 unit growth, and so when I say growth, this is kind of generically meaning growth or decay, okay? Growth or decay. So we called that B, right? We called that B. And from that, we could get the 3 unit growth factor. What is the 3 unit growth factor? B cubed. If 3 units of input go by, we end up multiplying by B 3 times for each unit of input that goes by. And we could easily get the 10 and the 16, right? B to the 10, B to the 16. For as many units of input that go by, the output is going to be multiplied by B that many times. That many times. Easy, right? And then we looked at partial unit, right? So if the 1 unit growth factor is B, then what's the 1/2 unit growth factor? Right? 1/5, 1/8. And we derived this a couple times last time, and you had something like it in your web work too. So knowing where those come from is important. So this is saying what number multiplied together would give you B, right? What number multiplied together twice would give you B? That's B to the 1/2. Okay. All right. So the moral here is that if you have one growth factor in a situation, you can easily get another one, right? So given any of these or others, they're directly transferable across this path here. But the question is, what about percent change? Do we have this direct transference of percent change? All right, well, let's test it out. We know that we can get the 1 unit percent change from the 1 unit growth factor. And similarly, from any growth factor or decay factor, we can get the corresponding percent change. We just practiced doing it, and you've had a lot of practice. So now the question is, do we have this direct transference between percent change the way we have it across growth and decay factors? So let's check that out. Suppose the 1 unit growth factor is 1.25. Okay? What's the 3 unit growth factor? Find it. Everyone find it. Find the 3 unit growth factor. And Colton, you got? 1.25 key, you got 1.95, that's right. Okay? Or something very close to 1.95. So, what's the 1 unit percent change? Right. If you multiply by 1.25, you're increasing that quantity, that output, by 25%. All right, what's the 3 unit percent change? 95%. So, is it times 3? This is a huge point. You can't take the 1 unit percent change and multiply it by 3 to get the 3 unit percent change. It's not 75%. It's 95%. So why is that? Why is the 3 unit percent change more than 3 times the 1 unit percent change? I know Danny has an idea. Anybody else? Adam? How about somebody new?
The growth factor's not times 3 either. It's not 3 times
Okay, it's not times 3. Well, it's to the third. So we've got the 3 in there. Yeah.
Well, the exponent's telling you to multiply the growth factor 3 times itself.
Okay.
So it'll increase the percent change.
It increases the percent change. Why does it increase the percent change? You're right on the verge of it. Michael.
Because every time you multiply an output to get a new output,
Yeah.
the output of the new is growing.
Right.
So getting the percent of that is going to increase exponentially.
Yeah, that was really well said. Did you hear that? So when you multiply, say, when you take a quantity and increase it by 25%, now you have a bigger amount, right? And you're going to take 25% of that, which is going to be a bigger increase than the first increase of 25%. So while 25% is staying consistent, just the amount in output goes up because you're taking the same percent of a higher value each time. So the cumulative effect of that in this case is not increasing totally by 75%, but the cumulative effect is to increase by 95%. So you've heard of this idea of compound interest, right? That's what compound interest is about. Interest building on interest. So as your quantity is growing, you keep taking a greater amount when you take the same percentage. Okay? So percent change is not directly transferable. That's the moral. But given a percent change, we do have a roadmap to another percent change. What is it? How we need so let's just do an example. Ready? If the 1 unit percent change is 2.5%, what's the 16 unit percent change? So I'm here, right? I've got this, and I want this. It's right in front of you. Yeah, Jed.
We have to go through the growth factor.
Exactly. That's why I'm showing you this map. So just tell me the roadmap here.
So if there's a 2.5% increase,
Yep.
the 1 unit growth factor is 1.025.
Okay.
And then, so we multiply that, we do 1.025 to the power of 16, since it's the 16 unit growth factor.
Okay.
If we find the value of that, we convert it to a percent change.
You nailed it. You see that? So if you stay on the road, then you can do it. You just got to stay on the road. There's no roads between percent change. Okay? So what is 1.025 to the 16th? Tell me. Nice, one person, nice and loud.
1.4845.
Okay? Percent change?
48.45%.
And thank you for that enunciation. And what is 2.5% times? I would say 2.5 and multiply by 16. Take 2.5 and multiply by 16. Is it going to be more or less or the same as 48.45? Less. What is it? 40. If you take 2.5% times 16, you don't get that compounding effect, 40%, which exists. So instead, you get 48.45%. So what's our roadmap? Our roadmap is always go through the growth factors to get percent change. Do it again. Go. The 3 unit percent change is 79%. Find the half unit percent change. Go. So if you want to make a stop along the way at the 1 unit growth factor, that can be helpful. Oops, sorry. There we go. So if you can't go directly from 3 to 1/2, some may be able to, some not. Go through the 1 unit. Go through the 1 unit first. Is this Riley? Did you get it, Riley? Tell me.
So I got 10.19%.
No. Okay, but talk me through it. Talk me through it.
So I started with the 79%,
Mhm.
added 1 to get the growth factor of 1.79.
1.79.
Then I took that to the 1/6 power.
1/6. Does that get us from 3 to 1/2? Good. And so,
So that got 1.1019. And so that would just make the percent change 10.19.
so I wrote it as the 1 unit first. 1.79 to the 1/3 would be your 1 unit growth factor, and then to the 1/2 again would be the 1/2. And he says 1.019, so the percent changes 10.19. Any questions? Anybody have a question? Make sense? All right, let's get some decay in here. So we got a decay now. 1/5 unit percent change is negative 1.8. Find the 10 unit percent change. Is this Diana here? Did you get it? Not yet? Did you get started? What'd you do first? Okay. You're trying to get the 1/5 unit growth factor or decay factor, I should say? Did you get the 1/5? Nine. The growth factor negative? Yeah, that's negative. Did you guys get it up there? How about Joshua in the back? Did you get it? Okay, Matt. No. Chad. Sorry.
Alright, so you take the one minus 0.018
Right?
to get the growth
Good? What is it?
So you get 0.913.
9.
8.
I'm hearing 3. Are you saying 3?
Oh, 0.913.
Okay. Yeah, I was like, I don't think there's a 3 in there.
So then after that you take that number and bring it to the power of 5 to get the 1 unit.
Oh, good. Okay, cool. So you want to go to the 1 unit first. That's fine. And you can take that to the power of 5. Good?
And that's when you get the 0.913.
Okay. Like that?
And then you take that number and bring it to the power of 10
So in all, we took the 0.982 to the power of,
to
to
the 50.
the 5th, to the 10th.
And you get
.40, 325. Cool. All right. And?
And then 1 is that number you got to get the percentage.
And I think is that negative 59 something? So it's a little dicier with the decay, right? Because you keep having to subtract from 100, okay? When you go back and forth. So make sure you follow that. How many people got that before I wrote that up there? Majority. Okay, good. The rest of you, hopefully you're settled. It makes sense what we did. So yes, so switching, we know that switching between percent change and a decay factor is a little bit trickier. You have to really understand the decay factor is the amount you keep. So you got to subtract or take it from 100 or subtract from 100. One more. Go. Negative 34%, 1/2 unit change. What's the 1/8% unit change? More practice. You want to do it? No, you already did the first one. I know you can do it. You have a question? Is it a question? I'm thinking someone new here. Let's see. Evelyn, how did it go? Okay, take me through the first half. Okay. She got the 1/2 unit decay factor of 0.66. Okay, good. How are we going to get the 1/8 from that? Oh, 1, cool, yeah. Which is? Is that, what'd you do to the 0.6 to get the 1 unit? Squared it, right, good. All right, then? So this is totally valid. What she's doing is great. So you can always take a middleman step at the 1 unit growth or decay factor. In this case, decay factor. So you took 0.66 squared and did what? You took that to the 1/8. And what'd you get? Non-zero. Someone else get that? Okay, so the 1/8 unit decay factor is 0.9013, so the percent change? 90% change, right? Oh, minus 9.87. Good job. Okay. Anybody have a question? Check Blackboard for homework. Not sure if there's going to be web work or not. For sure there will be written on for Wednesday. We can get started on. It'll be updated today sometime. Happy Friday.